why everyone's talking about GPUs, not CPUs when it comes to AI. I mean, your CPU is the brain of your computer, right? Imagine you have a huge, complex math problem to solve. A CPU is like a brilliant professor. It can tackle any part of that problem, one step at a time, with incredible speed and precision. It's a master of sequential tasks, handling your operating system, web browsing, and all those complex, single-threaded jobs flawlessly. If the task is like following a detailed recipe, the CPU is your Michelin star chef, executing each step perfectly in order. Now, a GPU is different. It's not one professor, it's an army of thousands of students. Each student isn't as brilliant as the professor individually, but they can all work at the same time. AI training, especially for things like deep learning and neural networks, isn't one complex problem. It's millions of simple, repetitive calculations that all need to happen at once. Think of it like coloring in a giant picture. The CPU, our professor, would color one pixel at a time, very carefully. The GPU, our army of students, gives each student a crayon and has them all color their own small sections simultaneously. This is what we call parallelism. GPUs were originally designed for rendering graphics in video games, which involves calculating the color and position of millions of pixels on your screen, all at the same time. It turns out, the math required for this is very similar to the math used in training AI models. It's all about matrix multiplication and other linear algebra operations done on a massive scale. So, while a CPU is a sequential processing powerhouse, handling one complex task after another, a GPU is a parallel processing beast. It has thousands of specialized cores designed to do one thing really, really well. Massive parallel math. For AI, where you're adjusting millions of parameters based on massive data, having thousands of cores working in concert is a game changer. The GPU's architecture allows it to process huge chunks of data in parallel, drastically cutting down the time it takes to train a model from months or even years to just days or hours. That's the real reason modern AI runs on GPUs. It's not that CPUs are bad, they're just designed for a different kind of work. For the massive, parallel workloads of AI, the GPU's army of cores simply crushes the CPU's sequential approach. It's the right tool for the right job. So next time you hear about the latest AI breakthrough, you'll know it was likely powered by the incredible parallel processing might of a GPU. Thanks for watching, and if you found this helpful, be sure to like and subscribe for more tech deep dives.